Hi, thank you very much for watching this video. My name is Julio and I am the Application Engineer Training Lead here at DesignPoint. I wanted to share this video for those of you who are looking for some additional information in FEA, especially in SOLIDWORKS simulation. And primarily we're going to be discussing the meshing aspect. Meshing is one of the most important steps in setting up your FEA study, given that the mesh can be directly related to the results that you will obtain. Let's take a look. Let's begin by taking a look at the meshes that the software has to offer. We have the standard mesh, the curvature-based mesh, and the blended curvature-based mesh. The standard mesh is good when trying to create a symmetrical mesh. It supports multi-threaded volume meshing and is great for uniform geometry. If you are looking for a mesh that is going to create lower number of elements with a high aspect ratio, this is going to be your friend. Then we have the curvature-based mesh, and by default, this is the one that comes selected in SOLIDWORKS 2021. It automatically creates additional elements in higher curvature areas. It is the fastest mesh, and it's great whenever you're dealing with some complex geometry. Last, we have the blended curvature-based mesh. This is great for failed meshes. If you have a mesh of a part that it's maybe too complex and you're having trouble meshing it, try to give it a try to the blended curvature-based mesh, since it's great working with this type of designs. It even gives you the option to calculate minimum element size based on your design geometry. Given its robust capabilities, it will result on being the slowest mesh. Time to dive deeper into our mesh. So as I mentioned, meshing is one of the most important components of your simulation. What it does is that it breaks your model into small portions, which is called elements. One quick tip is to always try to simplify your CAD model as much as you can. This is going to help your simulation mesh to run faster. Now, you can end up with a coarse mesh or a fine mesh. A coarse mesh is going to have larger element size, but it's going to solve quicker. Now, this does come at the cost of results, so you may end up with some less accurate results. The fine mesh on the other side is going to create smaller elements, but since you have smaller elements, it will end up with having a larger number of elements. This can make your simulation to run significantly slower. Once again, it's going to be based on the number of elements that your FEA will have. However, a finer mesh can result in more accurate results. Great. Let's walk together through the mesh feature itself. So when you go to create a mesh inside SOLIDWORKS simulation, you will be prompted with a couple different steps. First thing we're going to do is we're going to decide which mesh we are going to utilize. Remember, we have the blended curvature-based mesh, the curvature-based mesh, or the standard mesh. Depending on the mesh that you choose, the control options to control the element size will change. If you choose the curvature-based mesh, for example, you'll be able to control the maximum size for your element, as well as the minimum size for certain elements. Then you can also choose the number of elements around a circular hole or opening, and also the ratio. So this would be the transition as your mesh progresses from a larger element size to a smaller element size. The second option will be to specify the overall parameters as I was mentioning. We can use the lever tool on the top, or you can just enter the element size once again for maximum or minimum. Then we can also have the ability to let the software know what the element quality is. You can choose between a high quality or a draft quality. High quality will produce second order elements, while draft quality will produce first order elements. One significant difference in between them is that draft quality elements can have your simulation solver run quicker, However, it will have relative less accurate results for stress values. Let me show you another tool. So, as we have discussed a coarse mesh and a fine mesh, it may be very easy for many of us to say, okay, well, I want very accurate results, so I'm going to use a very fine mesh. Well, if you do this in a global parameter, you're going to end up with an extreme number of elements. This can have your simulation run for long periods of time. An optional approach that we can do is to apply mesh control. What mesh control is going to do is that it's going to define your mesh in areas of interest. It could be a face, it could be an edge, anything exactly that you need. And we'll take a look at that inside SOLIDWORKS simulation. Okay, let's take a look at an example where we evaluate a coarse mesh, a fine mesh, and a mesh where we have defined mesh control. Let's begin with the coarse mesh. To create the mesh, I will have my SOLIDWORKS simulation static active, and I will right-click the icon that says mesh and select create mesh. In here, you can see that I have my mesh density, where I can decide in between a coarse mesh or a fine mesh. If I expand the mesh parameters, I can look at which meshing I'm actually using. So we can use a standard mesh, the curvature-based mesh, or the blended curvature-based mesh. For this example, we're gonna continue to use the curvature-based mesh. You can see that as I move my lever, the parameters on the bottom will change. Once again, let's move it all the way to the coarse. I can take a look at the mesh quality to see the number of elements that this mesh will produce, and now it is set to high. We'll continue to use high quality elements. I'll come here to definition and hit OK. Now we can take a look at our mesh for our part. Now let's take a look at the number of elements that this mesh has produced. I can right click my mesh icon once again, and I will select details. This window will show data about our mesh. In this case, if I look under total elements, it has produced 10,190 elements. Let's switch into a fine mesh. Once again, I will right click my mesh icon and I will select create mesh. This time, I will continue to use the curvature based mesh, and I'm going to use my lever all the way to fine. I will select OK. And let's take a look at the mesh that it has generated. Let's right click our mesh and let's look at the number of elements that have been created. So we went from 10,000 to 37,525. Okay, so we have seen running a coarse mesh and a fine mesh, and we saw that the numbers were quite significant different. Let's take a look at an optional approach. In our case, our main area of interest, we're gonna say it's gonna be right here. Okay, so this fillet area. Now, if I was to define a fine mesh, it's gonna make it fine all the way throughout the model, and excessively fine in areas that are not of interest. So what I can do is apply mesh control on the areas that I have some interest, maybe some stress that can develop there, and run a coarser mesh in the other areas. Let's take a look how we can do that. So I will right click my mesh and I will select apply mesh control. So I'll do apply mesh control and I will go ahead and select the faces that are interest. You can do faces, you can do edges, and you can also do vertices. And here I will tell the software how fine I want my mesh to run. Now pay attention that I've been using the lever tool. In most instances, I like to enter an exact value. So you can use the measure tool to help you understand how small of a size you need to enter. But in this case, we're gonna just continue to use the lever tool. I'll hit OK. And then now I'll go ahead and set the parameters for the global mesh. So I'll do create mesh. And this one, I'm just gonna run it somewhere in between fine and normal. And I'll continue to use the curvature based mesh. Okay, so let's just set it up down here. We are using under mesh quality, high quality elements. So that would be second order elements. Hit OK. And that should run the mesh. So you can see now that it's a bit coarser, okay, in other areas. However, as we approach or we apply the mesh control, the mesh begins to transition to a finer mesh. Okay. We can take a look at the quantity of elements. So let's right click, hit details, and this one generated a total of 19,152. So the coarse mesh generated 10,000, a fine mesh generated 37,000, and this aspect generated 19,000. So I hope that this helped you to better understand how you can apply mesh control to your models. Don't go ahead and define a fine mesh overall, because that can end up in your simulation running a lot longer than needed. Great. Now that we have set up our mesh, it is time to understand if our mesh is good. There are a couple parameters that you can evaluate. One will be the aspect ratio, and this one will directly quantify your element shape. A value of 1 means that it is a perfectly shaped element. You can also take a look at the number of elements, and you can also take a look at the number of elements with an aspect ratio less than 1. We usually like to strive for this value to be between 90 to 99%. However, this will depend on your model's complexity. Last, you can utilize cut plots and use them to evaluate the mesh beneath your model surface. We'll take a look at how we can access these values inside SOLIDWORKS simulation. Now that we have generated our mesh, let's take a look at the quality of our mesh. To do this, we'll begin by taking a look at the details. So once again, I'll right click mesh and select details. And we already saw that this mesh ended up in having 19,152 elements. We can see the maximum element size and the minimum element size. One thing that I want to take a look at is the percentage of elements with an aspect ratio less than 3. You can see that it's producing right now about 99%. And percentage of elements with an aspect ratio greater than 10 is set to 0. Now, please be mindful that these numbers will fluctuate based on the complexity of your design. Let's continue to take a look. Let's go ahead and create some mesh quality plots. So I will right click my mesh and I can look at mesh quality plot. And here I can take a look at aspect ratio, my mesh, or even Jacobian ratio. So let's take a look at the aspect ratio and let's hit OK. So in here, it will produce a plot with a legend letting us know the aspect ratios.